Hi, I'm Paul from Test Data Services, and this video is going to show you how Micro Focus's latest version of LoadRunner 2020 Service Pack 2 works with Gatling. So this is a page from the documentation, and it's clearly showing a whole lot of information here on how to set up Gatling so you can use it with LoadRunner. And this video will walk through a very simple script with 2 requests in it, and I'll run that side by side with the traditional web HTTP HTML so you can see the difference or the similarity. And just note that it says here that it's a tech preview feature. You don't need a license at the moment to use Gatling in the LoadRunner controller, but that may change in the future. So that's good to know. But the way the actual users work is each user in LoadRunner will have a scenario that it fires up. It fires up a Scala script, and the Scala script itself contains all the instructions on how many actual users. So without any further ado, I'm going to just show you straight away a run. So this run is running with 50 web HTTP HTML users, traditional ones, and 1 Scala user. This 1 Scala user will actually fire off 50 users and run them for a minute. And now we can see over here that we've got 100 transactions passed, 200 passed, 300 passed. We're doing about now 80 requests per second. There's 1 request per transaction. To show you what the scripts look like, this is the Scala script. That's it. It includes really 2 requests. A request to API testdataservices.com.au as the base URL, and then this is the like the endpoint, and this is a query parameter here. So that's a subscription key, and that's to get a saved user ID. I'll put a link up in the top right-hand side on more information on using them. And then once you get an identity from a saved user ID, you might want to grab the password so you know how to log on as that user ID. So that's all the script is doing. We are fetching the UID of the individual with this check JSON path, and we get this person UID value back, and then we save it as a variable called identity UID. And then in the next request, this exec HTTP request to retrieve password, we actually hit that same endpoint. Hit the endpoint with this URL, but the UID is this variable that we've just fetched. So that's how you grab information from one request and then feed it forward into the next request. To show you what that actually looks like, the actual call that I'm doing is this one here to get a saved user ID. Every time I do this, I'm getting a user ID. This was left over from a test I just ran for a client. And in that environment, you couldn't control the user ID. You would get a 7-digit, 7-character user ID when you registered. And but I linked that back to the identity. And then once you've got an identity, you can fetch that identity, and then you can fetch from there password 5. So that's the context of what I'm doing. So we've just run that test, and let's just now analyze the results. When the next test is running, I'll show you the other script, the HTTP HTML script. So you noticed when we were running that the test was actually showing web requests per second and transaction response times. Once the test is finished, you can do post-test analysis with a bit more detail and more control over granularity of reporting. We can look though straight away, and we can see gatling.tds, which all of the transactions from Gatling are prepended with Gatling, and then the simulation name was TDS. The average response time for get existing user ID was 46 milliseconds, whereas in the HTTP HTML script, it was 65 milliseconds, and the retrieve password was 89 milliseconds in Gatling and 130 milliseconds in web HTTP HTML. Normally they're a bit closer. I've run this a few times, now closer. Let's look at it in a graph. That's why. When we first started, we had a few slow responses. Let's just fix that, because it's not really fair to compare if we do that. Elapsed time, and let's just ignore the first 15 seconds. So now we've done a global filter on all of the results, ignoring the first 15 seconds. So now we can see very similar responses. If we now look at that summary, the average for get existing user ID via Gatling was 45 milliseconds, and it was 44 with the LoadRunner script. And then with retrieve password was 88 versus 89. So what I'm really showing you here is very similar response times, which is awesome. The transactions per second, you can see they're quite similar also. So if I compare, this is get existing user ID from Gatling, is the one I'm trying to highlight. I can't make it bold, never mind. And this is the one from LoadRunner. So anyway, you can see here quite similar. What I'll do next is I'm going to open that script and go here, view script. Now where it says inject constant concurrent users of 50 for 60 seconds, we're going to change that to 500. When we change it to 500, it's going to do what it says. It's going to go up to 500. I've actually run with this with 1,000, which is great. Save. Now when I push save and play, it's going to run the same 50 users with the web protocol, just to show you what that script looks like. So this is a traditional web HTTP HTML script. And it's doing the same thing as the Scala script, as the Gatling one, when it eventually comes up. All right, so what we're doing here is we're doing a JSON fetch of the data returned from each of the calls, but in LoadRunner fashion, we're doing it with a WebReg save param. And we enter that before the call, then we execute the API call, and then that retrieves that value. And then we then insert that into the URL for the subsequent call. So in this case, the identity ID. So if I hit play on this, we'll see it does a compile first. And we can see that the blue text shows us that it fetched an identity of this, and then it looked up the password for that identity, and this is the password for that identity. Okay, so that's that. Now our test is pretty well run, I expect. Yes, it has. So in that short time, 1 minute and 18 seconds, we did 31,000 transactions, which is not surprising. If we now do analyze results, so the pretty impressive thing is that we can now run in a LoadRunner scenario as many users as we like that are Gatling users, and then really leverage the other protocols that LoadRunner offers. Like I use TrueClient almost every day in my testing for browser-based load testing, and that really works well. So that means I can combine them, which is awesome. So great facility that Micro Focus have implemented. So here we go. Average transaction response times. You can see we had a couple of slow ones to start with, and then it stabilized out. And then transactions per second, we can see that we've got more than 200 per second of each of the Gatling transactions, which I think is pretty good. So the other advantage is because this is LoadRunner, you can then leverage all of the power of LoadRunner analysis, which is great. And then from the scenario itself, you can even export all the results to InfluxDB. As per another video, I'll put that up in the top right-hand side as well. everything that's been collected from Gatling and from traditional virtual users can then be shoved off to Influx for whatever purpose that you want to use it for. So this is a quick introductory video, and I'll do another one with a bit more detail, with a bit more sophisticated real-world script. I hope you find this useful, and all the best. Have a great day.